Alright, in this video we want to learn about a really important number in math. It's a kind of a somewhat mysterious number. It's somewhat like pi in that it's a number that goes on forever with no repeating pattern, and it's called e. And if you want to find e on your calculator, I'll show you where to find that in just a second. But e is named after a famous mathematician. His name was Leonhard Euler. Euler is spelled, some people pronounce it Euler. I say Euler. And E equals this number. It's 2.71828, and then it goes on forever. And like I said, I'll show you in just a sec where to find that on the calculator. What's interesting about E is it's kind of like pi. Pi is not a number that human beings kind of invented. I mean, arguably we didn't invent any numbers, but the point is pi is something it exists in nature. Pi is the relation between the diameter of a circle and its circumference. Every circumference of a circle is equal to pi times the diameter, or you might be more familiar with this one, 2 pi times the radius, because the radius is half the diameter. E is kind of like that, so I want to show you where this comes from. This was explained to me a few years ago, and I found the explanation to be very good, so I'll try to reproduce it here. We can think about where E comes from based on this formula right here, which is this formula is the formula for compound interest, which we'll talk about pretty soon. But I just want to tell you what this means. You use this for finding out how much money you make. Let's say when you invest money. A stands for the final amount of money you make, and you calculate A by multiplying the principal. P stands for principal. It's the original amount of money you invest times 1. The 1 stands for 100%. That means you're getting back all that you originally invested. Plus you get something extra. You get the rate that you're investing at. R stands for that. N stands for the number of times per year they compound. That means how often do they calculate interest. So if they compound once a year, N would be 1. If they compound every month, N would be 12, and so on. And then this N is the same, and T stands for time in years. So I want to show you just a really simple example. Let's suppose we're just investing $1. That's why all of these examples have 1 right here. So we're just investing $1, and let's suppose our rate is 100%, and 100% as a decimal is 1. If you just move that decimal twice. So 100% rate means you're doubling your money. Right? If you have $1 and you get 100% of $1, that would be another dollar. So now you're at $2. So that's why the 1 right here stands for 100%. And then we'll compound it by different amounts. So we'll compound it, instead of doing every quarter, let's change that to every month. We'll compound it every month, and then we'll see how much money do we get if we do it every week, every day, and then even every second, because the way the computers are, there's hardly any limit on how often you can compound. So let's start with every month. So if N, in the case of every month, N would be 12, because there's 12 months in a year. And I think I forgot to mention T stands for time. So the reason these are all ones is because we're just doing it for 1 year. Alright, so let's calculate how much money would we have if we compounded our $1 12 times a year, so once a month. So I've already done that for us. If you plug that in, we get $2.61 approximately. So $2.61, that's if we compounded every month. If we did it every week, well, there are 52 weeks in a year, so now we're going to put a 52 there instead of a 12, because we're compounding it every week now. So let me just change that to a 52, and we'll change that to a 52 and press enter, and you can see now we get $2.69. So that's this one right here. I just want to show you what happens as we compound more and more often. So that's $2.69. What if we did it every day? Well, there's 365 days in a year. So now we'll change that number and that number to 365. So let's see how to do that. And by the way, if you want to quickly get a long string of numbers that you typed, you don't have to want to retype it. You can hit second enter, and that will just bring back the original kind of a calculator shortcut. And then if I want, I'm about to overlap with that parenthesis, so I can hit second delete, because that's where the insert button is, and then I can just insert another number in there. Those are some nice calculator shortcuts. And alright, so every day we get $2.71. And you'll see what's going to happen in just a sec. Okay, again, let's not do it every day. Now let's do it every second of every day. So that's going to be 365 days times, let me see if I can squeeze this in here, times 24 hours a day times 60 minutes in an hour times 60 seconds in a minute. And then we have to do the same thing on the top up there. So this is going to be 1 times 365. So obviously that's a huge number. And I'm going to show you kind of what happens here because it's pretty interesting. So let's do second entry, and I'm going to have to insert, and let's put parentheses around this because otherwise it's only going to divide by 365, and that's not what we want to do. So I'm going to put another parentheses there, and then we will insert a bunch of numbers here. So second insert, and then we want to do times 24 hours a day times 60 minutes per hour times 60 seconds per minute. Close that parentheses, and same thing up here. So times, I know that's about to get cut off. I'll move the screen in just a sec so you can see that. Times 60 times 60. So let me move that so you can see it a little bit better. And alright, so here we have it, and we press enter, and we get that number 2.71828. Now I told you I'd tell you where to find E on the calculator, so here's where you find it. You go to second, and then right above the division symbol, it's a little bit hard to see on mine because it's kind of small, but look on yours. Right above the division symbol there's a little letter E. Looks like that. You press enter, and notice that it's almost the same. It's not quite perfectly accurate, and that's because we only compounded every second. If we did it every millisecond, every nanosecond, which means a billionth of a second, it would be even closer. So the point is this: if you were to, let me just write this down, this is 2.718, it's accurate out to 5 decimal places. What's happening here, and this is why E is so interesting, E is kind of creating a tug of war between the bottom of this fraction and the top. So here's what I mean by that. If you were to do this, if you were to make this number infinitely large and you were to make this exponent infinitely large, this right here would equal exactly E. You would get E dollars out of that if you were to, talk about it in terms of money. So what's happening here is this thing is getting really small. It's getting really close to 0. 1 divided by anything, if it gets large enough, is going to get smaller and smaller. And this thing is going to infinity. So it's like a tug of war between 0 and infinity. What's 0 to the infinity? It's hard. In some ways, it's hard to say. If you took a really small number and you raise it to a really enormous number, well, that's going to be pretty close to 0, but then you still have this 1 that's adding on to it. So E is kind of fascinating because it shows up in nature a lot. It shows up when you're talking about population growth or growth of money, which we'll talk about later. It's not a number that we invented, that we assign meaning to, like the number 365. We didn't invent that number, but we did decide, or not quite decide, it kind of depends on the motion of the planets, but there's that many days in a year. Okay, there's 7 days in a week. 7 is kind of a number that has significance to us. 24 hours in the day. 12 inches in a foot. All these numbers are numbers that we didn't per se invent them, but we kind of, in some cases, we assign meaning to them. Like 12 inches, I would say more so than 24 and 7. Those were externally set for us by the length of the days. But the point is, E is not like that. E is something that exists in nature, and it talks about, or it's relevant to how things grow relative to how big they start out as. So that's just a primer on what E is and where it comes from. It's the number 2.71828. We'll be using that further in our next problems.